Delving into the wires, understanding the Internet's origins, connections, and pathways. The Internet, ubiquitous in modern life, often feels like an intangible entity, a web of information seemingly existing apart from the physical world. Yet, this vast global network of interconnected computers has a tangible genesis and relies on a complex infrastructure to span continents and oceans. Exploring the Internet's origin, the intricate pathways of its data, and the physical backbone supporting its flow offers a fascinating glimpse into the technology that underpins our digital age. From Cold War seeds to global web, tracing the Internet's genesis. The Internet's roots lie in the Cold War era, born from the U.S. Department of Defense's Advanced Research Projects Agency, ARPA, seeking a communication network resilient to attack. In 1969, the first message traversed ARPANET, the precursor to the Internet, establishing a connection between UCLA and Stanford. ARPANET's decentralized architecture, allowing data routing around damaged nodes, proved crucial for its survival and future development. Over the next decades, a confluence of factors, including the invention of TCP/IP, Transmission Control Protocol/Internet Protocol, and the emergence of personal computers, fueled the Internet's exponential growth. The invention of the World Wide Web by Tim Berners-Lee in 1989, introducing user-friendly hypertext formatting, solidified the Internet's transformation from a research network to a global information and communication platform. Invisible pathways, navigating the Internet's physical lines. While the Internet may appear ephemeral, its operation depends on a substantial physical infrastructure. Data travels through a complex network of interconnected cables, satellites, and terrestrial and undersea fiber optic lines. These lines, often bundled together and buried underground or laid along the ocean floor, form the Internet's backbone, carrying the electrical signals that translate into the information we access online. Fiber optic cables, transmitting light pulses for faster data transfer, are the dominant medium, crisscrossing continents and spanning oceans through submarine communication cables. These cables, some stretching thousands of kilometers, are carefully laid and protected, facing threats from natural disasters to intentional damage. From land to space, expanding the network's reach. Beyond terrestrial infrastructure, satellites play a crucial role in extending the Internet's reach to remote and underserved areas. Geosynchronous satellites, positioned in a fixed orbit 35,786 kilometers above Earth, provide Internet access to regions where laying cables is impractical or impossible. Low Earth orbit, LEO, satellites, operating closer to Earth, offer faster latency and are gaining prominence, particularly for broadband Internet in remote areas. However, satellite Internet, while expanding reach, has limitations compared to fiber optic, including higher latency and susceptibility to weather conditions. Looking ahead, the future of the Internet's pathways. The Internet's physical infrastructure is constantly evolving, driven by increasing demand and technological advancements. Innovations like underwater fiber optic drones and mesh networks using high-altitude platforms aim to bridge connectivity gaps and provide Internet access to the remaining offline populations. Additionally, research into space-based networks using constellations of LEO satellites promises further expansion and potential improvements in speed and latency. Understanding the Internet's origins, the physical pathways carrying its data, and the ongoing efforts to expand its reach provides a deeper appreciation for the complex machinery behind our digital lives. From the Cold War seed that grew into a global web to the intricate network of cables and satellites carrying our information, the Internet's physical infrastructure is a testament to human ingenuity and its insatiable thirst for connection and information sharing. As technology continues to evolve, the way we connect and communicate through the Internet will undoubtedly continue to shift, shaping the future of our relationship with this ubiquitous and transformative technology. This research paper offers a foundation for further exploration into the many facets of the Internet's infrastructure. Deeper dives into specific areas like underwater cable installation, the technical intricacies of satellites, or the environmental impact of our online activities can further enrich our understanding of this ever-evolving technological marvel.